Scott Wimberly here with FabTech Systems to help present the instructions for the manufacturing of our neuromuscular PDE system. Our PDE system for children is in 175 millimeter length as well as 225 millimeter length. With that, we're building the same type of modular component bracing that you've come to expect with the PDE, and we're offering a wide variety of options using the techniques that people currently have for working with regular thermoplastic bracing. Our modular system, as I said before, is in 175 millimeter length, as shown here with the part numbers. And then we have a new 225 millimeter length here that's available in 7 categories as well. And there are the part numbers for that. These kits are sold like our other systems in fitters kits as an option. We offer fitters kits which have category of springs 1 through 5, as well as some components to manufacture a brace. That is offered in 175 millimeter length and 225 millimeter length. The kids system does have its own unique anchor system. The anchor system for the kids line is as a standard TPAC 4. The TPAC 4 is included with your spring purchase, as well as it is available separately. The TPAC 5 is for doing composites work, as more of a specialty or heavy duty anchor, and is available for purchase separately. So let's go ahead and get started with the manufacturing. The first thing we like to look at when we are evaluating a cast and getting it set up for manufacturing is let's go ahead and get the posterior aspect of the cast itself marked up with reference positions for our anchors. The way that we do that is we mark from the plantar level at the heel up the back of the cast. We place a mark at 4 inches and up at 6.5 inches for the 175 system. In the 225 system, we mark up the same 4 inches from the floor, and then we mark approximately at 8.5. These spacings for us give us the reference on the back of the cast, as well as it ensures that we're placing the spring in a repeatable position for all of the different braces we make. This offers us the ability to duplicate results, and this position also ensures that all of the hardware is up outside of the shoe, so the patient has less to contend with for fit. To get started, what we're going to want to go ahead and do is we're going to want to attach our anchors to our spring component. The anchors themselves, there is an upper anchor and there is a lower anchor. What makes them upper and lower anchors is they have a slightly different radius where they go up against the cast so they can fit a little bit more flush. To make it a little bit easier to see, we did go ahead and put some indicator marks on the anchors themselves if you look at the backside of them to help you understand which way goes up. Now taking this assembly of the spring and the anchor system, we'll go ahead and place it on the cast, and we're going to go ahead and start looking for best fit. Here you can see we've placed it against the cast, and I've got some decent gapping here distally on the foot plate and proximately up on the anterior cuff. If we move to a different view here, you can see that this view here on the left, the spring is in what we would consider to be the quote-unquote normal orientation. That is with the bend in the spring more proximal right here, bend in the spring more proximal. And on the other side, we have the spring itself flipped upside down with the anchors placed on the other face of the spring. This is upside down and backwards. So once again, normal, upside down, and backwards. Both of these positions, from a functional point of view, will give good results. And so in best practice, we normally move for the position that gives us the spring that fits the model the best. So here for the cast that we're using for this presentation, you can see that on the right here, upside down and backwards appears to be the best fit. So we're going to go ahead and set it up and manufacture this job in that orientation. To go ahead and move on further down the line, we'll go ahead and use normal thermoforming techniques, and we'll make our inner liner for the AFO. This inner liner can be of any material. Once again, this is just a snapshot of what you could do. It's not a snapshot of all you can do. So the techniques that you would commonly use when you're manufacturing an AFO in your facility are all still techniques that you can apply to this. Once we've gotten our inner foam liner pulled, we'll go ahead and add a little bit of material, and we'll place the spring back on the cast to see how it looks and check the fit. Before we bond the spring into position, we need to make sure that we get the alignment of the spring right. What we're looking to do when we talk about the alignment of the spring is I'm looking to get the face of the spring, its width, perpendicular to the line of progression, and attach it to the posterior aspect of the cast. The way that we accomplish this normally is we'll place the cast into a horizontal holding fixture, pipe stand, pipe vise, bench vise, what have you. We'll present the cast horizontally. We'll rotate the toe down, and then we will rotate the toe to represent the toe out that the patient has. This gives us a cast orientation as we show right here in the orientation in the illustration. And then I'm going to want my spring to now be bonded on with a perpendicular or level surface to this imaginary line of progression that I've got there. When doing bonding, what we're looking for is a good attachment of those anchors to the back of the cast, as well as something that'll look good if it goes into the final job. For most of this, we use the Plus Series Adhesive C1S with the point and shoot applicators. If you're not familiar with the product, definitely check it out. We'll attach the upper and lower anchors using the point and shoot C1S. And then, if needed, we're going to come back through and we're going to fill any large undercuts that are between the anchor and the model itself. These undercuts will leave flaws in the final job, and it may compromise some of the overall strength of the device. So we just go ahead and we fill all those undercuts with a little bit of additional C1S to make sure that we don't have any problems there. Once everything is fully bonded, the adhesive's hardened and cured, we'll go ahead and remove the spring component from the job. Now we have the anchors on the back of the cast in the proper orientation that we're going to need them in to reattach the spring later. This now means that all of our alignment has been saved and we're ready to go ahead and do the final aspects of the plastic pull. A lot of times we'll add an additional layer of hosiery over the top of this setup device to help a little bit to make sure that we've got some very precise vacuum forming. You can see the hosiery over the top here, and in this particular case it is a little dusty looking because we've added powder. All of the liners in this particular setup are going to be removed, and new liners will be glued back in once it's complete. So once everything's set up, we'll go ahead and thermoform using our standard techniques. Here we've applied a nice graphic to the plastic using a transfer paper to try to make it a little bit more special. The plastic's been pulled, we're going to want to immediately verify that all of the areas around the anchors and the hardware have pulled down all the way and are precisely formed. We want to ensure at this point that we have no air bubbles that could create gapping or voids here, so that we've got the strength and integrity we're looking for in this device. Once the item is cooled, we can go ahead and start our final processing. This will be the point we take it into the machine room and start the grinding. As we're grinding this job, it's super important that we pay attention to this, the anchor face itself. The anchor face itself is this flat surface I'm highlighting right here. That's what the face of the spring is going to butt up against. So the spring face and the anchor face will meet, and we want to make sure that those areas are flat and true. The flatter this surface and the truer this surface, the better fit we get. And also we want to make sure that we don't grind this area thin and create a weakness. Here you can see in this illustration that we have some raised areas where our anchor hardware was protruding here and here. But this area that I'm highlighting right now, we want to make sure that when we do our grinding to remove these raised round areas, that we don't grind this flat area up too much. Taking a look at it here, you can see I've removed the raised sections quite well, but you can still see on the flat surface here, I've got some purple pigment from that transfer graphic we did. What this is doing for us, it shows us that we've gotten the raised area down and we've kept the thickness in our flat space like I wanted. From this aspect forward, this is a lot like trimming out and finishing a regular AFO. We'll go ahead and we'll mark the job up, and we'll go ahead and cut it out according to the trim lines and do the finish work that's needed. When it comes time to start bolting all of the hardware together, use the supplied hardware, which is a hardened plated hardware. Use the supplied hardware with Loctite. We're going to want to use at least a 242 Loctite or stronger. This will help ensure that the hardware doesn't vibrate loose under use. Also with this, when we're bolting things together, we want to be sure that the screws go completely through the metal inserts in the anchors. It's kind of a test fit. So here's the job with the spring bolted in place. And here is some finished snapshots of that same job. All said, very easy to use, very, very common practice when working in thermoplastics. This next overview of the TPAC 5 is to show the basic method of use. The TPAC 5 is for use with lamination. It is a more advanced process, and it does cross over into our instructions for laminated orthosis that we've got on our website. So this is a quick addendum just to give you an idea of how the anchors work so you can implement them into the designs. Our TPAC 5 does consist of our lamination anchors, our introducers, some low-profile hardware, our lamination toolings, and our layer packer. Here's a snapshot of how everything bolts together. With using this type of anchor, we're going to always start our layup by adding the introducers. Normally, we would already have these anchors bonded to a cast before we started adding materials. But for this instance, to show how they're used, we just got it sitting here on the table. So we go ahead and we add our two white introducers and we get ready to add material. When we put the material over the top, we're going to want to spread the weave of the material around the introducer so that we're able to get our layup materials to go all the way down flat onto the anchor around those posts. We can use our packing tool here to come back after each layer and compact it down onto the flat face of the anchor there so that we get some good coverage with the materials. After we've added all the materials that we're going to add, we'll remove the introducers, leaving the clearly visible faces of the anchor showing, and we will bolt on our lamination tooling. This now leaves the anchors ready to be laminated. For any other information on laminated bracing and how to do that, please do go to our website, fabtechsystems.com, and look for the lamination instructions for the orthopedic PDE system. Having gone through what we do with the kids, let's go ahead and talk about what we're doing in more of the adult sizing, the 250 millimeter system, our version 2. We're building this same modular reactive braces that you've come to expect, but we've got it set up now so that it can be done with thermoplastic systems, just like you'd expect from us. That system as it sits right now is TP250 categories 1 through 5. In that, we are offering 2 different anchor systems initially. The TPAC 1 and the TPAC 2. The difference between the TPAC 1 and the TPAC 2 is that the TPAC 2 does have a pre-cut polypropylene infused with carbon fiber for reinforcement of the anchor section. Anyone that's a high activity user in this anchor system would want to go ahead and order the TPAC 2 so they can add additional carbon fiber reinforcements. And then we also have a laminated version of this as well, the TPAC 1 HL, just like the laminated anchors that we just showed for the pediatric and adolescent line. This lamination anchor set itself allows the integration of laminated cuffs or laminated foot plates to do the job. We do sell fitters kits for the 250 line. The fitters kits have all of the springs 1 through 5 and the components to fabricate a brace. In the 250 line, we do offer alignment shims for multi-plane alignment. This helps you do angular adjustments of a brace after it's been manufactured to work with specific fitting needs that you may encounter. Much like the way we set up our last brace, we're going to go ahead and we're going to establish our anchor positions. These anchor positions are 5.5 inches off the floor and 10.5 inches off the floor. This is going to give us the placement that we're looking for with our spring and anchor combo. So bolting the anchors onto the spring, a lot of times we will take some tape and we will cover the anchors to keep them from getting dirty with the composite adhesive. We'll check the spring and anchor combo on the posterior aspect of the cast. You can see here we've got our marks for our positional heights. Just like we did with the kids line, we're going to make sure that we bolt the spring on in the proper alignment. That proper alignment would be the flat face of the spring perpendicular to the line of progression. Here you can see if we put the cast in a horizontal stand and we rotated the cast until the foot was pointed down, and we took that and we established that the line of progression is plumb, and we rotated the toe out or toe in depending on the patient to match their anatomical needs in the transverse plane, we would now have the cast toe down in the correct rotation. We can add the spring on the back, looking to be perpendicular to that line of progression or level. With that, we take the composite one, our C1S here. We add a liberal amount of glue to the anchors themselves. You can see here now that masking tape we put over the anchors is keeping all this adhesive from getting on there. We'll put the spring system itself on the cast in the correct alignment. You can see our reference marks right there, and we'll look out for any undercuts underneath the anchor in the model. Just like the kids line, we're going to want to make sure that we fill these spaces. And so filling these spaces, you can fill them with the same C1S that we used here, or you can do some touch-ups with clay or plaster. Normally we use the C1S just because it's so much faster. The additional layer of hosiery, now that we've got our anchors into position, be helpful for thermoforming. You can see here's the anchors with the final layer of nylon over the top of them. And we'll go ahead and pull our plastic. Here we did an American flag pattern onto the plastic, but it's just a polypropylene pull. With the plastic still being molten, we're going to have to open up the holes on those anchor plates so we have the ability to bolt everything together. What we'll do is we'll take a blunt, semi-pointed object. Here we've got an old screwdriver that we kind of ground a point onto, rounded it out a little bit, and we'll jab that into the warm plastic while the device is not fully cooled. This is going to leave us some really good index marks for when we come back and we drill the holes to open up those anchors. Once everything's cooled off, you can go ahead and trim the job off the model. This is the inside of the plastic after it's been cut and removed from the model. Here you can see we've popped the anchors out from the inside and we've unwrapped the tape, and it's left the hardware nice and clean. Taking a drill and using those marked holes, we'll go ahead and properly size and open up those anchor holes. What we're looking for is an anchor hole that's 6 millimeter in size. We don't really want anything any looser than that because we want a good snug interference fit. Once you've drilled your holes, you're going to want to check the anchor pockets for flaws and make sure there's no burrs or anything in the way there from drilling the holes. Sometimes when you press the drill through the hole here, it'll leave a burr to the inside edge. Then when we go to bolt everything down, it's going to create an irregular surface for the mounting hardware. So just be sure to check that. Make sure it's a flat surface. Make sure that the pocket is the same full thickness as we did with the kids' brace. And we can bolt things together. When we bolt things together, be sure to use the supplied hardware and a Loctite, 242 or stronger, to bolt these things together. Once they've been bolted together, ensure that the screws go the full length through the fastener. We want to make sure that the thread engagement on our anchors is at least 100%. We'd do 110% if we could, but 100% will have to do. This is another overview of the lamination anchor for this product line. That anchor system, the TPAC 1HL, is the composite alternative. For this illustration, we're going to show the process of applying materials. The anchor is going to be sitting on a table versus being attached to a cast as you'd normally see it. So here's our TPAC 1, here's our anchor. With the introducers. As we said before, the introducers help position the lamination materials around these raised posts in the aluminum anchor. When we push materials over the top, we want to be sure that the introducer comes through the weave pattern and that we get the weave pattern all the way down around the flat face of the anchor. To help compact things, we do have a packing tool that comes with this as well, and we can use that between the layers to come over the top and pack things down. Once we've added all of the materials that we believe we're going to need for this process, we will remove the introducers, leaving the faces of the anchors exposed, and we will add our lamination tooling and we will laminate as normal. For more on laminating and fabrication of composite bracing, do check our videos online at our website for the PDE orthopedic line. It's about an hour long, and it really goes through a lot of detail on this stuff that could definitely help you out. Using the 250 line, we do have the ability to create some really unique modular dynamic bracing systems using those thermoplastic materials processes that you're used to. What we've got coming here next, and I thought for a second I wasn't going to include this, but I figured I would go ahead and include it because this set of instructions will give you just some more visibility on ways in which you can include this component selection into your brace design. These instructions are actually the beta instructions that were created when the systems were being developed. They show a brace being manufactured, and most of what you see here is going to line up really well with what you've seen in the last two examples. However, there are some things in these instructions that are following this that are not going to line up. They are beta pieces. Colors and shapes may have changed. So just look at it for example purposes to help further understand the process and implementation to be able to utilize these tools for yourself. So this is the thermoplastic PDE process instructions that were built for our beta group. Our thermoplastic PDE system, as you can see here, as you're familiar with, we assemble the spring and the anchor. Once we've assembled the spring and the anchor, we mark our casts up like we're used to. These are the heights we're using in for each system. If you haven't noticed up to this point in the presentation, the kids line is purple. The 250 line is orange to help further clarify this system when we're talking about things. If you notice the purple, you know it's kids line. You notice the orange, it's the 250 or adult line. We're going to go ahead and place the spring assembly on the cast, utilizing those positions that we marked up. We go ahead and mask up those anchor faces with some tape. This does make cleanup so much easier when it comes time to do the cleanup. So we'll add a little bit of tape there. We'll put the spring back on the cast in alignment. And our alignment, as we said, is in a horizontal fixture with the toe placed down, using an imaginary line of progression that is a plumb line. We're going to rotate the foot so that the alignment of toe in or toe out in the transverse plane for the patient is correct, and then we'll attach the spring on the posterior aspect with the base of the spring plumb and level. So once we get our anchors in position, we'll bond the plates using our composite adhesives. We'll make sure that we don't have any undercuts there, and we'll go ahead and remove the spring, leaving our anchor plates on the model. In the earliest version, we placed screws in the anchor plates to help hold position. We added our nylons over the top of all of it to get ready to do our plastic pull. We pull our plastic, and then we were using the lamination tooling to press to get kind of a posted flat spot. This process didn't endure, but it was included in part of the beta group instructions. We pressed our spots, and then we trimmed off all the plastic. Once we trimmed off all the plastic, we were able to remove all of the waste material adhesive from the anchor because we had taped everything up, leaving a clean surface. And then we filled the space that we had used there with some soft foam to make sure that there weren't any problems with the patient feeling that stuff. In this particular device, we did a padded anterior shell, and we did a closure opening using the BOA system. The closure system could be placed either medial or lateral. Anyhow, those were the beta instructions. Like I said, some of the products changed, but it does give you more of an idea of the application in the general use of all of these products. Wanted to say thank you for choosing to use Fabtech Systems products. If we can ever help with anything, definitely do let us know. And if you want to get signed up for our Insider Track, go ahead and follow the link here. It's going to prompt email to get you on our list. So anyhow, thanks and good luck fabricating.